When considering electrical service options for a 2,500 square foot house with an additional 2,500 square foot addition to create a mother-daughter setup, the question arises whether two 200 amp services or a single 400 amp service with distributed subpanels is more efficient. The analysis indicates that employing two separate 200 amp services presents a more efficient solution. This conclusion is drawn from several key factors. Firstly, load balancing is significantly improved. Having two distinct services allows for a more even distribution of the electrical load across the two electrical panels. This balanced approach prevents the overloading of any single service, thereby reducing the risk of trip breakers or blown fuses, ensuring a more reliable and stable electrical supply. Secondly, enhanced flexibility is achieved with two 200 amp services. Each service can independently supply power to approximately half of the house. This independence provides greater flexibility in electrical usage and simplifies troubleshooting. Should one service encounter an issue, the other service can continue to power essential appliances and lighting, maintaining critical functionality. Thirdly, compliance with the National Electrical Code, commonly referred to as the NEC, is a crucial consideration. The NEC mandates that each dwelling unit must have its own dedicated electrical service. In the context of a mother-daughter house, this requirement translates to each unit needing its own service panel to meet code stipulations. Fourthly, cost effectiveness is generally better with two 200 amp services. The combined cost of materials and labor for installing two smaller services is typically less than the cost associated with installing a single, larger 400 amp service, offering a more economical solution. Fifthly, the efficiency of subpanel distribution is improved. Distributing subpanels from two 200 amp services is more efficient than doing so from a single 400 amp service. This increased efficiency is due to the ability to locate subpanels closer to the areas they serve, which reduces the length of wire runs. Shorter wire runs minimize voltage drop, ensuring more consistent and reliable power delivery to connected devices and appliances. Let's consider each of these factors in more detail. Load balancing is a critical aspect of electrical system design. An unbalanced load can lead to several problems, including overheating of conductors, nuisance tripping of circuit breakers, and reduced lifespan of electrical equipment. With two 200 amp services, the load can be divided such that each service carries approximately half of the total load. This distribution minimizes the stress on any single component and promotes a more stable and reliable electrical system. The flexibility offered by two 200 amp services is particularly advantageous in a mother-daughter house setup. Each unit can operate relatively independently, allowing for different usage patterns and energy consumption habits. If one unit experiences a power outage or requires electrical work, the other unit can remain operational, minimizing disruption. This independence also simplifies troubleshooting, as electrical issues can be isolated to a specific service panel, making it easier to identify and resolve problems. Adherence to the National Electrical Code, the NEC, is not only a matter of compliance but also a matter of safety. The NEC sets standards for electrical installations to ensure the safety of people and property. The requirement for each dwelling unit to have its own dedicated electrical service is intended to prevent overloading and to provide a clear separation of electrical systems. This separation enhances safety and simplifies maintenance and repairs. Cost considerations are always important in any construction or renovation project. Installing two 200 amp services is generally more cost-effective than installing a single 400 amp service. The cost of the service entrance equipment, including the main breakers, meters, and wiring, is typically lower for two smaller services than for one larger service. Additionally, the labor costs associated with installing two smaller services may be lower, as the work can be divided into smaller, more manageable tasks. The efficiency of subpanel distribution is another key factor to consider. Subpanels are used to distribute power to different areas of the house. The closer the subpanel is to the area it serves, the shorter the wire runs and the lower the voltage drop. Voltage drop is the reduction in voltage that occurs as electricity travels through a wire. Excessive voltage drop can cause appliances to operate inefficiently or even malfunction. By using 200 amp services and locating subpanels closer to the areas they serve, voltage drop can be minimized, ensuring that all appliances and devices receive the correct voltage. In summary, installing two 200 amp services for a mother-daughter house is generally more efficient than installing a single 400 amp service. This approach provides better load balancing, enhanced flexibility, ensures code compliance, is more cost-effective, and improves the efficiency of subpanel distribution. These factors contribute to a more reliable, safe, and efficient electrical system for the entire property. When planning the electrical system for this type of dwelling, carefully consider the load requirements of each unit. Estimate the total amperage needed for lighting, appliances, and other electrical devices in each unit. This estimation will help determine the appropriate size of the service panels and subpanels. It is also important to consult with a qualified electrician to ensure that the electrical system is installed in accordance with the NEC and local codes. A professional electrician can provide valuable guidance and ensure that the electrical system is safe and efficient. Beyond the initial installation, regular maintenance is essential to keep the electrical system in good working order. Inspect the service panels and subpanels regularly for signs of damage or corrosion. Check the circuit breakers to ensure that they are functioning properly. If any problems are detected, have them repaired promptly by a qualified electrician. By following these guidelines, the electrical system can operate safely and efficiently for many years to come. Choosing the right electrical service configuration is a crucial decision that can significantly impact the performance and reliability of the electrical system. By carefully considering the factors discussed and consulting with a qualified electrician, a well-informed decision can be made that meets the needs of the property owners and ensures a safe and efficient electrical system. It's important to understand the concept of electrical load calculation, which is a systematic method of determining the total electrical demand of a building or a portion thereof. This calculation is essential for properly sizing electrical services, feeders, and branch circuits. The NEC provides detailed guidelines for performing load calculations, taking into account various factors such as the square footage of the building, the types of appliances and equipment that will be used, and the anticipated usage patterns. Accurately calculating the electrical load is crucial for preventing overloading, which can lead to overheating, damage to equipment, and even fire hazards. Overloading occurs when the electrical demand exceeds the capacity of the electrical system, causing conductors to overheat and insulation to break down. This can create a dangerous situation that puts people and property at risk. By performing a thorough load calculation, an electrical system can be designed that is capable of safely and reliably meeting the electrical needs of the building. The NEC specifies different methods for calculating electrical loads depending on the type of building and the complexity of the electrical system. For residential buildings, the NEC provides a simplified method that takes into account the square footage of the building and the number of small appliance circuits. For commercial buildings, the NEC requires a more detailed calculation that takes into account the specific types of equipment that will be used and their anticipated usage patterns. In addition to the general lighting and appliance loads, a load calculation must also include the loads for any large appliances or equipment, such as air conditioners, electric heaters, and electric ranges. These large appliances can draw significant amounts of power and must be properly accounted for in the load calculation. Once the total electrical load has been determined, the appropriate size of the electrical service, feeders, and branch circuits can be selected. The electrical service is the main connection between the building's electrical system and the utility company's power grid. The feeders are the conductors that carry power from the service to the subpanels. The branch circuits are the conductors that carry power from the subpanels to the individual outlets and lighting fixtures. The size of the electrical service, feeders, and branch circuits must be sufficient to carry the calculated electrical load without overheating or exceeding their ampacity ratings. Ampacity is the maximum amount of current that a conductor can carry safely without exceeding its temperature rating. The NEC provides tables that list the ampacity ratings of various types of conductors, based on their size, material, and insulation type. It is important to select conductors that have an ampacity rating that is equal to or greater than the calculated load. In addition to the ampacity rating, the voltage drop of the conductors must also be considered. Voltage drop is the reduction in voltage that occurs as electricity travels through a conductor. Excessive voltage drop can cause appliances to operate inefficiently or even malfunction. The NEC provides guidelines for limiting voltage drop in electrical circuits. The NEC recommends that the voltage drop in branch circuits should not exceed 3%, and the voltage drop in feeders should not exceed 5%. To minimize voltage drop, it is important to select conductors that are large enough to carry the calculated load without excessive voltage drop. It is also important to minimize the length of the conductors by locating subpoles closer to the areas they serve. When designing an electrical system, it is important to consider not only the current electrical needs but also the potential for future expansion. It is generally a good idea to oversize the electrical service and feeders to allow for future growth. This will avoid the need to upgrade the electrical system later if the electrical demand increases. In addition to the load calculation, it is also important to consider the grounding and bonding requirements of the NEC. Grounding and bonding are essential for ensuring the safety of the electrical system and protecting people from electric shock. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. Bonding connects all of the metal parts of the electrical system together, creating a low impedance path for fault current to flow back to the source. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to follow these requirements carefully to ensure the safety of the electrical system. Finally, it is important to have the electrical system inspected by a qualified electrical inspector. The electrical inspector will verify that the electrical system has been installed in accordance with the NEC and local codes. The electrical inspector will also check for any potential safety hazards and ensure that the electrical system is safe to operate. In conclusion, designing an electrical system that is safe, reliable, and efficient requires careful planning and attention to detail. It is important to perform a thorough load calculation, select conductors that are appropriately sized, and follow the grounding and bonding requirements of the NEC. It is also important to have the electrical system inspected by a qualified electrical inspector. By following these guidelines, one can ensure that the electrical system is safe and meets the electrical needs of the building. Electrical systems are governed by various regulations and codes to ensure safety and standardization. Understanding these regulations is crucial for both homeowners and electrical professionals. The National Electrical Code (NEC) is the most widely adopted standard for electrical installations in the United States. It provides comprehensive guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect the latest technological advancements and safety practices. Local jurisdictions may also have their own electrical codes that are based on the NEC but may include additional requirements or modifications. It is important to comply with both the NEC and local electrical codes when installing or modifying electrical systems. Failure to comply with these codes can result in fines, penalties, and even legal action. In addition to the NEC and local electrical codes, there are also various industry standards and certifications that can help to ensure the quality and safety of electrical products and installations. Underwriters Laboratories (UL) is an independent organization that tests and certifies electrical products to ensure that they meet safety standards. Products that have been tested and certified by UL are marked with the UL listed mark. This mark indicates that the product has been evaluated for safety and meets the requirements of UL standards. The International Electrotechnical Commission (IEC) is an international organization that develops standards for electrical, electronic, and related technologies. IEC standards are used worldwide to promote interoperability and safety in electrical systems. The Institute of Electrical and Electronics Engineers (IEE) is a professional organization that develops standards for electrical and electronic engineering. IEE standards cover a wide range of topics, including power systems, telecommunications, and computer engineering. In addition to these standards organizations, there are also various certification programs for electrical professionals. The North American Board of Certified Energy Practitioners, NABCEP, offers certification programs for solar installers and other renewable energy professionals. The Electrical Training Alliance, ETA, is a joint training program between the International Brotherhood of Electrical Workers, IBU, and the National Electrical Contractors Association, NECA. ETA provides training and certification for electricians and other electrical workers. These certification programs can help to ensure that electrical professionals have the knowledge and skills necessary to perform their work safely and effectively. When selecting electrical products or hiring electrical professionals, it is important to look for products that have been tested and certified by reputable organizations and professionals who have been certified by recognized certification programs. This will help to ensure that the electrical system is safe, reliable, and compliant with applicable codes and standards. In addition to complying with codes and standards, it is also important to follow best practices when installing or modifying electrical systems. Best practices are generally accepted procedures that are known to be safe and effective. Some examples of best practices for electrical installations include using properly sized conductors, making sure that all connections are tight and secure, and protecting wiring from damage. By following best practices, the safety and reliability of the electrical system can be improved. In conclusion, electrical systems are governed by various regulations and codes to ensure safety and standardization. Understanding these regulations is crucial for both homeowners and electrical professionals.